Salam and welcome everyone. So today we're going to be working on the question on the screen that says a sample consisting of 1.00 mole of argon is expanded isothermally. So in this case, we've seen that we have an isothermal expansion problem where there is going to be an increase in volume. So V final is going to be greater than V initial, and the process is going to be occurring at constant temperature, okay, at 20 degrees Celsius from 10.0 dm cube to 30.0 dm cube. Calculate the work done when the process occurs against constant external pressure that is equal to the final pressure of the gas. So one thing you have to know is that whenever you're given a constant external pressure question and you're told to calculate work, what this means is that work equals negative P, as in the external pressure, right? Times change in volume. So the first thing you have to do is that you have to be able to find what pressure is, and we have, of course, what the change in volume is. Ignore the other parameters, which is the number of mole. Also ignore the fact that the temperature is given. Also ignore the fact that the volume is given in dm cube. Right now, let's just talk about pressure. Well, the question says against constant external pressure that is equal to the final pressure of the gas. If you've noticed, they did not give us what the external pressure value is. They just told us that P external is the same thing as P final. So the final pressure and the external pressure are going to be the same thing. Now, since this is a question where we're assuming that this is perfect gas, we're going to use the very important formula, which is PV equals nRT, right? And in this case, we're going to be solving for P final. So P final equals nRT, okay? And then this V, we're going to put this equation in terms of P final. So that's going to be divided by V final. So we're going to be using the final volume because we're looking for the final pressure. So if we're looking for the initial pressure, we'll be using the initial volume. So this is the reason why I'm having V final here and I'm not picking any other volume. So we have this now. We do the math. We use the number of moles that we're given, okay? Now we can use the number of moles, the gas constant, and the temperature. Number of moles we're given is 1.00 mole, okay, times 8.3145, okay, and that's going to be kilopascal, okay, dm cubed divided by mole Kelvin times the temperature, which is given to us. And the temperature here is 20 degrees. So 20 degrees to Kelvin is the same thing as saying 20 plus 273.15. So the temperature is actually 293.15. Sorry, 0.15 Kelvin. So we're going to have that here. So that would be 293.15 Kelvin. All of this information is divided by the final volume. So that would be 30.0 dm cubed. So we're going to cancel out dm cubed, um, dm cubed, Kelvin, Kelvin, mole, mole. So we're going to cancel all of this information out. And we would end up having P final equals 1 times 8.3145 kilopascal times 293.15. Yeah, divided by 30. So whatever this answer is going to be the answer for the P final that we're going to need to solve for the work. So yeah, this is just part of the process. So when we do that, we have 81.2465 kilopascal. So this is basically what this is. So this is actually the pressure. Now, don't forget that this kilopascal can be rewritten as 81.2465 times 10 raised to the power of 3. Yeah, Pascal. So that's basically what kilopascal is. So now this question is now asking us for the work done. So that would be W equals negative P final change in volume. But one thing you have to note is this: Pascal, right, is the unit for pressure. What is pressure? Pressure is simply force over area. So that is what pressure is. That's like the fundamental definition of pressure, force over area. Well, the units for force is Newton. So this is just make sure you remember your physics that you've done in college and in high school. Area, the the standard unit or the SI unit for area is meter squared. SI unit for force is Newton. So really, Pascal is the same thing as Pascal. Sorry, is the same thing as Newton per meter squared. That's like another way to denote Pascal. So that would be Newton per meter squared. So I wanted to put that information down first because we're going to be using that. But then let's also not forget what volume is, right? We're asked to find the change in volume. Well, we know what the change in volume is, right? The change in volume here is just going to be V final minus V initial. So that would be 30 point 0 dm cubed minus 10.0 dm cubed. So change in volume is going to be 20.0 dm cubed. So yeah, that's basically what you do. Now we see that dm cubed and we see meter. So we have a dm here, decimeter, and we have a meter here. And honestly, they cannot cancel out. They would need either the decimeter should be converted to meter or the meter to be converted to the decimeter. But the wise thing is for us to change from decimeter to meter. So that's going to be decimeter to meter. Well, let's not forget 10 decimeter, okay, is actually going to give you 1 meter. So hence 10 decimeter cubed, right, is going to give you what? Right? Sorry. So hence decimeter cube will give you how many meter cubed? Well, if we cubed both the right and the left of this particular equation, we're going to note, we're going to see that 10 times 10 times 10 is simply 1,000, and 10 times 10 times 1,000, dm times dm times dn is dm cubed. 1 times 1 times 1 is 1, meter times meter times meter is meter cubed. So that means for every 1 meter cube, you're going to have 1,000 decimeter cubed. So basically what I'm trying to do here is to go from decimeter cubed to meter cubed. So I'll use a black pen now. So yeah, so let's not now forget that if that's the case, where we've seen that the change in volume is 20.0 decimeter cubed. So we're going to do dimensional analysis and say 20.0 decimeter cubed times, we're going to have 1,000 decimeter cubed right here because we're trying to find it in meter cube, divided by 1 meter cubed. Well, since we're not dealing with decimeter, we don't want it in decimeter, we can cancel out decimeter, and then will be 20 divided by 1,000. So that's 20 times 10 to the power negative 3, which is the same thing as the change in volume in terms of meter cubed is going to be 0.020 meter cubed. So this is what we're actually going to input in this particular equation. So hence, work done here that we know it to be negative P final, change in V is the same thing as, so work done, negative P final, change in V. So that will be work done equals negative 81, 81.2465 times 10 to the power 3 Newton per meter squared. Okay, don't forget that's what Pascal is, times change in volume, which is 0.020 meter cubed. So of course we're going to do the math we know how to do best. Meter squared, remove the cubed. So that's going to be W work done is going to be negative 81.2465 times 10 to the power 3, okay, times 0.020 Newton meter, which is the same thing. Just remember that Newton meter is joules, same thing as joules, right? Just like Pascal is the same thing as Newton per meter square. So now we input this information to the calculator and we get negative, done equals negative 1624.93 Newton meter. So in 3 sig figs, we're going to get, because basically that's what our question is, right? We're given in 10.03 sig figs, 1.003 sig figs, 30.003 sig figs. So everything is in 3 sig figs. So work done is just going to be negative 1.62, okay, times 10 to the power of 3, since it's sig figs, Newton meter, or work done is negative 1.62 times 10 to the power of 3 joules. And I also wanted to quickly mention that the reason why our work is a negative is because the work is being done by the system. Whenever a system is doing work, like in this case, an expansion is going where there is like an increase in volume, the system is actually doing work. After the process has occurred, the expansion process has occurred, the system now has lesser energy. It's just like if I clean my room, after I'm done cleaning my room, I'm going to have lesser energy. So the negative in front of the numerical value is showing you how much energy has been lost through the whole isothermal expansion process. I wish you guys all the very best. If you have any questions, please put it in the comment section. If you want personal tutoring, I help students achieve A's and succeed and get honors before they graduate, or basically as they're graduating. So one thing I wanted to say is if you have any questions, email me at shuhabitutoring@gmail.com. I tutor middle school, high school, and college level students. And I also do group and individual tutoring for students. So if you have any question, email me at shuhabitutoring@gmail.com. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.